Hi everyone, my name is Thomas Kim. Today is 4th of August 2022. This is my 36th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB. This is also my 5th episode for C++ 23 Deducing this. In this episode, I will discuss the differences between auto forwarding reference or L-value or R-value reference and decltype auto. We will implement forward like this function. C++ 23 standard introduces deducing this. Please double-click this link. You can print as a PDF on your machine like this. Then if you open this PDF file, you can find forward like. We will implement forward like this function as described in this text. Also, I will explain this part of code, how to implement it properly. In C++ 23 standard, deducing this will be introduced. This new syntax will change the C++ language syntax significantly. If you want to learn up-to-date modern C++ programming, please keep watching my videos. Please understand that I am busy these days reading The Blind Watchmaker. Today I finished up to chapter 6. Now I am reading chapter 7 of this book. After reading this book, I will read Extended Phenotype, this book. So I cannot film my videos as frequently as I used to. Anyway, if you want to follow my current and future sessions, you have to watch my previous videos listed here. Episode 35. Please double-click this link. If you haven't watched my previous episode, episode 35, you may not be able to understand my current and future sessions. From episode 35, please double-click this link. Show in folder. Unzip it on your local machine. Rename the folder 36 forward like. Copy this, paste it in your working directory. Open up Visual Studio Code. Open CPP 17 2023 parallel. From File Explorer, right-click, copy, select folder 36, paste. Rename forward.cpp, Ctrl-V. If you haven't watched my previous videos listed here, you may not understand my current session. I will fold it up. CPG types. From here, Ctrl and delete. So I deleted. Void test forward like not good. In the main, copy the function name, copy, paste it here. In this namespace, if you scroll down, you can find like T. We created this function in our previous episode. Control Home. In our previous episode, we created like T. Now, template, type name T, decltype, auto, forward like, auto, this is forwarding reference U. Using result T, we are using like T is this argument. Then decltype U, we defined result T. Then return std forward result T. We can pass U like this. Please understand that I implemented this function from this PDF forward like here. I would copy this text and paste it for your reference. Please understand that we implemented like T here, and I used exactly this syntax. This is result T. Then we forward. This is exactly the same. Now here std vector captured 1, 2, 3, 4, 5. Auto named captured. We captured by value. This is a forwarding reference. Self. Return type is decltype auto. std cout. We print out type of self. cpg get type category self. std and std cout address of captured 0. You can say captured 0. std and now here don't miss semicolon. decltype auto n. We call named capture. This is Lambda. std cout type of n. cpg get type category n. std and then paste n equals n. Then we put another carriage return. Now open up Microsoft compiler. dir cd 036 forward like cl. You need to have Microsoft C++ compiler version 19.32 or above. If you have older version of Microsoft compiler, you cannot build CL, EHSC, SED, C++ latest. Please understand that we are using C++ 23 standard. This syntax is called deducing. This is supported in C++ 23 standard. So we need to use latest C++ compiler switch. Then forward.cpp fe m.exe, hit enter. 129. We made a mistake here. Return cpt. This namespace is cpt. Okay. Here, this is type alias for cpt, cpg types. End of namespace cpg types. So we are using cpt, then forward like this. We have to provide decltype self. This type is the object type for this template parameter t. Then we pass captured. We are returning captured. Hope you understand this syntax. Now we rebuild CLSM. So we are calling named captured. This is an instance of closure type of Lambda. Okay, an instance of closure type Lambda. It is named, so L value reference. In this line of code, we are displaying the type of self. Self is L value reference. The type of n is L value reference of type vector. N is displayed properly. Hope you understand. Please examine it very carefully. Now copy this, copy, paste. We will copy this, copy. Here I will overwrite This is now U. U means unnamed. We have to call lambda. We are calling this lambda. Then type of U, U. Now we rebuild. CLSM. The result is wrong. It is crashed actually. But you have to notice the type of lambda. Lambda 2 is this lambda. This is lambda 2. Lambda 2 is unnamed. Unnamed closure type. In case of lambda 2 unnamed, it is R-value reference. In this case, named. This lambda is named. In this case, it is L-value reference. So this is lambda 1. This is lambda 2. This is lambda 2. In case of lambda 2, this is R-value reference. In case of lambda 1, this is L-value reference. Also, this is wrong. Now, copy from here up to this point. Copy, make demarcation, paste, scroll up, test forward, member, perfect. Change your function name like this. Copy, paste it here. Now, disable it. Scroll up. Please understand that this is lambda 1. This lambda is named. In this case, we are calling unnamed lambda. Unnamed. Here, I will copy this code. Copy. Paste it here. Address of N0. Copy. Paste. Address of U0. Now scroll up. We will be using forward member. Copy, scroll down, forward member. Please understand that in this lambda, capture is member. This capture is data member of closure type lambda 1. In this lambda, capture is data member of closure type lambda 2. So forward member, we are forwarding capture. Scroll up. Here, template, type name, T, concept, L value, REFC, SED, is L value, reference V. We pass T, copy, paste, I value, reference C, is I value, reference V. Now copy this, copy, paste it here, forward member. Here, if context for L value REFC, we pass T. Please understand that we are passing the type of T. Then this code, else using return T std remove cbreft decltype, we pass U. Here I misspelled decltype. Return T, we use std move U, or I can say result T. This is member. I will fix like this. Member. Now we created forward member. If T is L value reference, we use this function. This is the same forward like defined here. Otherwise, I value REFC. Then we move member like this. With this function forward member, we are calling from here, then here. Now we build CLSM. So in the second case, in the first case, lambda 1, this is L value reference. This lambda is L value at this line of code because this lambda is named. In this case, in the second case, lambda 2 is unnamed. So R-value reference. In this function, the address of capture, the first element address F50, the first element of U, F50, exactly the same object, because we moved using forward member, and it works perfectly. If you want to compare with this one, SED, cout, SED, and there, you can compare like this. CLSM. In the first case, it failed. In the second case, it works perfectly. So, I fixed a problem in this documentation here. I fixed the error in this documentation like this. Now I will disable this part. Void test autos. Copy this, paste it here into M5. Auto 2 ampersand B6 auto 2 ampersand A M, we pass M, SED cout 1 type of B, CPG get type category V, STD, and there, copy, paste. This is to A M. This is case 1. This is case 2. Please compare the type of B, the type of AM, like this. CLS rebuild, CLSM. We initialize B with pure R value 6. The type of B is R value reference. This is R value reference. In case of AM, we initialize with L value M. The type of AM is integer L value reference. Auto can bind to either L value reference or R value reference. Now decltype oro S5 case 3. I will copy this, paste it here. 3 type of S copy, paste. This is DM. This is case 4. For DM. Now we build again. CLSM. In case of 3, the type of S is int. In case 4, we initialize DM with M. Now it is int. Now here decltype oro std move M case 5 copy, paste. 5 mm. Now we build again. CLSM. When we move L value, then take using decltype oro. Now R value reference. If you haven't missed my previous videos listed here, you understand what I am saying. If you missed or you have forgotten what we learned in our previous videos, you may have difficulties understanding this part of code. In summary, oro can be either L value reference or R value reference. Decltype oro can be non-reference, such as int, double, etc. Also, L value reference and R value reference. In a nutshell, decltype oro equals oro plus oro forwarding reference. If you remember this, also you have CPG getType category. You can solve any C++ type system problems.